So I'm going to start out with a couple of random things about me, kind of break the ice a bit, if I can get this to do what I want. There we go. So first off, I'm actually an Eagle Scout, if you don't know what that means. It's a program in the United States for young men from 11 to 18. Eagle Scout is the highest rank. It means I did a lot of work once upon a time. Doesn't mean much for what I do now. I actually studied English literature in university. It's not exactly the career path you'd expect. There's a story behind that as well. You can ask me sometime if you want. My first real job, this was right after I finished high school, was working as a courier. It means I drove around the city. I was living in San Diego. I drove around carrying packages between big offices that had to be delivered within a couple hours. It was actually a very fun job. You get to meet a lot of really cool people, and you get to learn the way around the city. This is a good one. When I was 15, I actually promised myself I was never going to be a professional programmer. I'm doing pretty good so far. So the reason for this actually was I always considered programming to be a hobby, and I very much enjoyed it, and I was afraid that if I let it become my job, it wouldn't be fun anymore. Thankfully, I was mistaken, and I still very much enjoy it, even though I work in it now. My favorite song is actually called Revelator by Claude Debussy. It's from the Romantic period. It has nothing to do with the modern romance. I played the tenor saxophone in high school and in college in a marching band for a total of 6 years between the two of them. That's also a lot of fun if you've never done it or if you've never seen it. If it wasn't obvious from the previous things I said, I didn't meet an Orthodox Jew for the first time until I was 21 years old. I lived in a very isolated community. It wasn't isolated from other people, it was just isolated from Orthodox Jews. At the end. You're going to have to track me down and ask me. When I was in middle school, I got banned from the school computer system because I guessed the administrator password. Yeah. Sorry? I didn't do anything. I got caught playing around with one of the settings because I wanted to see what was possible once I had it. And the IT guy there caught me and was very unhappy that I had guessed his password and decided the appropriate punishment was I couldn't use it. I was only in 7th grade, so it was a year and a half I wasn't allowed on the computers while I was in that school. I still claim it was an unfair punishment. When I was in university, I actually failed Calc 2 3 times. I kept on taking it, which, since my degree was English literature, my counselor kept on telling me I should stop taking it. He says, you don't need this class. Why are you taking it? You clearly can't pass it. And I told him, no, I can pass it. I just got to get up in the morning. Because it was an 8 a.m. class. I wasn't going. I used to manage a company called Soros Software before I was at Revelator. And I named it Soros actually from the Pasuk, Ki sarisa im Elokim v'menashim v'tuchal. The word for Yisroel actually comes from that Pasuk, from sarisa, which means to struggle, to combat. And it was actually always one of my favorite parts of development was this concept of having to really struggle and really to work hard and to dig deep into understand the code. And so I took from the word sarisa, I took the word Soros. And the most important of all is that I think off by 1 errors are the most difficult part of programming. Okay, let's get to the actual fun stuff. So now I'm working at a company called Revelator. I've been there for about a year. In total, I have been developing for about 17 years. My official title is VP of Engineering. What that means, if you're not familiar with corporate structure, is that I'm in charge of making sure that we're able to execute according to the plans that we make. So if the product team delivers us a spec and says we need to create this product, I need to make sure it actually gets built, that the appropriate teams are working on it, that it's appropriately scheduled, that we are able to shuffle things around when there are changes to the schedule or when there are unexpected things that come up. I like the development more than that, but I only get to do development these days about half my time. I spend the other half doing management, which is also good. The company itself, Revelator, we're in what's called music tech. So what we're doing today, you can see in the first section, is that we're connecting musicians directly to these big stores, Spotify, iTunes, Amazon. We make it easy for them to get their content to every single store they want to with a couple of clicks. Once the content is there, we make it easy to get paid. If you don't know anything about royalties in the music industry, they're really complex and they're really slow. Before the age of digital, it was normal for an artist from the time that someone bought a song, if they went into a store, they bought a CD, or if they listened to something on the radio, from the time that happened until the artist got paid. Anybody have any idea how long that took? Huh? After the grandson, okay. 6 months, okay? A year, okay, so it was a year to 2 years from the time that someone spent money until the time the artist actually got anything, which is a very long lead time. It led to an entire industry of all kinds of interesting loans, and labels were fronting money, and it created a lot of really lucrative deals for the middlemen who were between the artist and the guy buying the song. Digital obviously made that easier. In the world of digital, you can get paid in about 2 months, which is a lot better than 2 years, but it's still not good. So that's where we are today. That's one of the things Revelator wants to change. We're moving towards, anyone who uses our system gets paid in 2 months, which is the fastest we can do from the stores directly. It takes them that long to get us the data. We're aiming to get to daily payments. And one of the ways we're going to do that, which is what I have here under where we're going to be, is using blockchain technology. So we're building what's called the Artist Wallet, which is going to allow us to be able to pay you directly, and it's going to be payments based on future earnings. It's technically what's called a microloan. It's not quite the same as a normal loan because the earnings are more or less guaranteed. We have access to a daily trend stream from almost every DSP that tells us, here's how much has been played. The only reason they don't pay us is that they don't finalize how much they're going to pay until the end of the month. And they finalize it based on figuring out how many people listed in how many different countries with different subscription types and free and whatever, and then they'll figure out, here's how much we're willing to pay you per stream this month. We're building a business intelligence-based product that's going to be able to predict what the expected value every stream is, so that we can give you a loan based on the actual value that you're going to be able to get, and it will look like, on the surface of things, that you're getting paid every single day for music that you was listened to that day. Last point, and this is part of the reason I agreed to come here tonight, is we're actually hiring. So if this stuff sounds interesting to you, or if you're interested in the things I talk about during the speech, I'd love to hear from you. You can send me an email. We can chat. Let's see if we can move this on. Okay, so the topic of the speech tonight is Solid. I hope everyone here has actually at least heard of Solid. Let's start with one question. Just by a show of hands, who here learned Solid while you were in school or whatever education you did? Oh, almost nobody. Okay. Does everyone know what Solid is? Okay, raise your hand if you don't know what Solid is. Let's go that way. About half the room has never heard of Solid. Okay, so I'm going to give you a bit more of an introduction then. Before we get to the intro on what it is, raise your hand if you've actually used Solid in your job. Okay, not so many, maybe 3 or 4. Okay, so this one's probably not going to be so relevant, but I have a list here of common complaints I hear about Solid. I'm obviously an advocate for this, so I'm going to try and defend some of these things. But people tell me that it is over-engineered, it's a waste of time, it's irrelevant, it's useless when you actually try to apply it on any kind of practical level. You only need it if you work with a broken paradigm. This is a very common one. You hear this a lot from functional programmers. Any functional guys out there? Hey, one guy. You feel this way about Solid? No, okay. I hear this a lot from functional. Functional is relatively new to the scene compared to some of the other paradigms. And functional programmers like to say that they can solve all of your problems. You believe that? Great. What's your name? Arya? Arya Labe. So ask Arya, he'll tell you he can solve all of your problems, just switch paradigms. I do believe there are a lot of advantages to functional. I'm not trying to say it is a bad paradigm or that I don't believe in the things it can bring us, but it does not mean you solve every single problem, which is what we often hear. And then the last thing, which is kind of true but misses the point, is that it makes your software bigger and more complex and harder to deal with. All right, Arya Labe disagrees on that one too. Let's get on. So I'm going to go into some examples of why it matters. Let me just quickly tell you what it is, since we have some people that don't know. Solid is a collection of 5 principles in development. These are major principles that are designed to make sure when you build your code, you can easily change it in the future. We know code changes. We know that we have new requirements. We know that we have bugs and we have to go in and fix them. And we need to make sure that the code is as flexible as possible to do that. These principles are principles that were developed over the course of 30 or 40 years by a lot of good developers based on what they actually saw. The types of bugs they saw and the types of things they saw made a difference in preventing them. There's a total of 5 of them. I'm only going to talk about one of them in depth tonight, just in the interest of time. And I'm going to briefly mention another one. I'll quickly tell you what they all stand for right now and give you like a 1-sentence explanation. Actually, I think I have a slide for that. Yeah, we'll do that in a minute because we have a slide on that. Let me first talk about why it matters. And I have 3 kind of case studies on this. This is actually based on things from Revelator. The first one is in MRR. If you don't know what that stands for, that is monthly recurring revenue. That is one of the metrics that big companies use to measure how well they're doing. It means how many people are subscribing, how much are they paying, what kinds of plans. And at Revelator with MRR, we have a problem that we've lost about $20,000 is an estimate. This is coming from my CEO and from my sales team. But they tell me we've lost about $20,000 to our competitors, our direct competitors, because our clients say, you can't do X. There's something that's very important to me and you can't handle it. And even if our product is better in other ways, if what they need is that one single feature, they're gonna walk away and go to a competitor. $20,000 is a big number. And the reason that it costs us is because even though the vast majority of these cases are just barely beyond what we can do, we do like 80%, 90% of what they want, but we have bad design throughout the code. And it makes it so that there's no reasonable path forward for us to add that feature without doing a significant, large refactoring of our code base. And that's not an investment that we're able to make on a per feature basis. And so this is one example where if we had considered solid design principles from the beginning, in most of these cases, we'd be able to get that MRR. And I can give you just a couple of really simple examples here. We don't have any demo data on our API. We sell an API. And if you want to use it, you have to just trust our documentation and sign up and start paying, and then you can use the real thing and hope it works for you. It's a really great feature. We don't have demo accounts for people who want to try out our system. Again, you have to sign up and give it a try. We don't have transactional accounting reports, so we deal with a lot of money. We have millions of dollars passing through our system, being processed and figured out where it's going, and we cannot provide you with any report, an accounting style report, that gives you a breakdown of where that goes. We have the data, but it's in a very disorganized and difficult to manage format. So we don't have any way to produce the accounting style report. We don't have detailed usage data. If you log into our system, we can't tell you, without you calling us up, we can't tell you how much have you used this month and how much are you going to pay at the end of the month when your bill comes. And our last one, we don't have the ability, we have white label clients, guys who pay us to resell our product. They have scalable vector graphics, SVG files, that they want to be able to use because it looks nice on mobile. We can't support that. And so they end up with this really bad experience. They say, well, why are we bothering to make your white label if our mobile users are going to end up losing out? Every one of these things, something we want to address, but again, it's something we can't because our design gets in the way of us being able to address it. Our second case study here is cost. So we have a transcoding system. This is one piece of it. The stores that we work with all require a different format for audio. The best format, the most common format, is what's called a FLAC file. But there are stores that want waves, there are stores that want high quality audio, there are stores that actually want MP3, believe it or not. And we have to do what's called transcoding. We have to take the source file we get from the customer and turn it into a brand new type of format. We added 2 new formats recently, and it roughly doubled the amount of transcoding work we have, which that's fine, we're used to that. The place the problem came up is that transcoding is handled inside of our larger distribution services, and there's no way to really factor it out without breaking the rest of the services. So in order to be able to handle the additional transcoding work, we had to double the size of one of our virtual machines, and we're currently paying an extra $1,000 a month on this that we don't really need. We need only one very small piece of that, but because of the way that the service is designed, we're stuck with that extra cost. And until we redesign it, we can't get out of it. I actually like to joke, when I first joined, they told me that we had a microservice architecture. Everyone's heard that term, right? So we don't have microservices, we have 6 monoliths. Okay, and kind of our last point here is in terms of handling change. This one's actually a positive story, thankfully. We're right now at the end of a 2-month project. We've actually been rebuilding our report processing infrastructure. This infrastructure is what's responsible for dealing with all the individual transactions that come from stores, and that we have to then be able to hand off to our customers to tell them who they owe what money to. We process on average 750,000 lines of data per day on our system, and we support over 100 different types of reports on this system. So at the end of this redesign, we've been in this for 2 months. We're about a week and a half away from finishing, and I just got a call from the head of product last week with a new requirement that it turns out he forgot to put in the spec. This is a classic problem, right? He comes to me, he says, oh, it turns out there's something called the license period, and when an asset comes in, we can only match it to an existing asset if it's still within a valid license period. Otherwise, we can't match it. This is a pretty critical component of the system because we need to take the source lines and match them to the existing catalog data and use that to generate all the revenue reports. If we need to change the way that works, that's going to change everything. It affects all 750,000 lines. It affects all 100 parsers. So you might say it's time to panic, but it actually wasn't, because we had designed this system. It was a new system, and we designed it with solid in mind. The part of the system that was responsible for handling the asset matching was actually already factored into its own independent service, and it was a couple of lines of code to add this feature in. This is something we're able to do at the very end of the sprint, make a significant change, and it's fully tested. We have both integration and unit testing and everything to be able to cover it and to make sure that even though we made a change, we haven't damaged any other part of the system. And that's really what we get out of solid design principles. That's really what we get out of being careful with the way that we architect our system. So if I was kind of summarize this and to say that we have a crash course in what software design means, I have on the right here kind of a quote about it. It is design your code with future change in mind. That's what this all boils down to. And I have a list here of some things you may have heard of in the past. We talked about Dry, we talked about KISS, Yagni, you've probably heard of some of these principles. They all boil down to that one same thing. We know change is going to happen. We need to make sure whatever change we can predict and to whatever degree we can be prepared for that change, we're designing now in the very beginning for that change to happen. Okay, so let's talk a bit more about Solid itself, the specifics of it. I'm first going to tell you the 3 principles I won't mention. I don't think these principles are unimportant. Every one of these principles matters a lot. But first off, I have a limited amount of time. They told me I only get 40 minutes, otherwise you guys will get bored. And there's also things that matter more on a day-to-day basis and matter less on a day-to-day basis. So the ones we're not going to do are what's called OCP. That's the open-closed principle. OCP, first off, is really hard to understand. It has a terrible name, and most people I talk to can't really grasp why it matters or how they're supposed to use it. It's also only mainly useful if you're building a framework of some kind that you expect to be consumed by a lot of different people. If you're building something only for yourself, you probably don't need OCP. Next one is LSP. It's the Liskov substitution principle. This is probably the most boring principle I can teach you. The reason is it's very academic. It's very, very important. If you ever deal with inheritance hierarchies, if you ever deal with classes and how they interact across inheritance hierarchies, you have to understand LSP or you will make mistakes that will cost you. But most people on a daily basis aren't doing that. We typically use pretty simple classes that maybe have one level of inheritance and nothing beyond that. And the last one is what's called DIP, the dependency inversion principle. This one's actually very important, but Lamaisa, you probably don't have to think about it because you have a DI framework, a dependency injection framework, and it makes it basically automatic. For all the cases that it really makes a difference, your framework is going to push you in the right direction and you're probably going to end up building something that conforms to DIP. I'm not saying it doesn't matter at all. I'm not saying there aren't cases where you can mess this up, but you're probably going to get it right. The other 2 that aren't on the board here, which are the ones I'm talking about, are SRP. That's the S of Solid. That's the single responsibility principle. I've spent quite a long time talking about that tonight. That's really the most important for most average developers. And then we have what's called ISP, which is the interface segregation principle. I'm just going to do a quick case study on it because it's got one of the coolest features of code, in my opinion. So we'll take a look at that towards the end. Every object, class, or method should do one thing and one thing only. Just get a show of hands. Who thinks this is a good definition for SRP? Okay, 3 people. I'm glad to see it's not so many hands because I think this is a terrible definition. I'll tell you why. First off, this is the most common thing you'll hear about when someone says, what's SRP? Do one thing only, do it well. I've heard this phrased many, many, many ways. It's not the point. It maybe has something to do tangentially with SRP does for us. So let's look at a second possibility here. Every object, class, or method should have just one reason to change. Who thinks this is a good definition of SRP? A couple more people. So this is actually the official definition. If you look in the books, if you look at Robert Martin, who's the guy who originally put this stuff together, this is the way he phrases it. I don't think this is so helpful, because I think for most people, the first thing they're going to say is, what the heck is a reason to change? Everything changes all the time. I'm always changing a lot of source code files. What do you mean I should have one reason to change? Every single person wants me to do something different with it. And so I have my own kind of phrasing of this, which I just find is easier for most people to understand. And that is that the goal of SRP is that we want to make it safe to change software behavior by making sure that everything that depends on something, it depends on a method, class, or object, has the same expectations. And that's where that word responsibility comes from, expectations from that method or class. SRP means that I don't want to be in a situation where there are 2 completely unrelated components of my system with different expectations for my code that both depend on that code. When I have that happen, I'm ripe for regression bugs, and we'll see some examples of how that works in just a moment here. Everyone's heard of regression bugs? Okay, regression bugs mean you have something that works today, you implement a new feature, suddenly it doesn't work. Everyone's encountered regression bugs? If you haven't heard of them? More people, good. Okay, so let's talk about this in action. I'm going to talk about first report formats. So the way that the stores I told you about before pay us, pay the customers, is they have what they call content owners. These are the guys that, as far as the store is concerned, are responsible legally for the rights to the music that gets played. And the content owner is basically never the artist. It's some kind of a label or a distributor or someone else. The store will send them one lump sum payment for every single song that they've distributed, and it's up to them to break that down. So along with the payment, they will send a CSV file, typically, of transactions, where every line represents a single song that was streamed. It's broken down by country, by date, by track, by release. There's a whole bunch of metrics it's broken down by, and we need to ingest those reports to be able to figure out how much money was made to generate our royalty runs. I have here on the screen right now a sample. This is a snippet of a real report file. This is obviously a very small snippet of it, and you can see that they have a ton of different data on here, including how much money was made and where. I want to show you a second one. This is a sample of another report file from the same company. It's a company called Yandex. And if you haven't heard of them, they're a Russian search engine, and they also provide music services. This is another one. Can you guys see all the way on the right? You see the revenue columns there? I can't see it on my screen. Yeah. Can anyone see the difference between these two files? Here's the first one again. Here's the second one. Anyone see a difference between these two files? I can't hear? Okay, that's a good idea. Precision is different. Anything else? There's a very important difference here that was missed by us because we messed up SRP. All right, so if you look on the far right on the first report, you see the column that says at the top, total in USD, total payable USD? You guys can see that? Okay, look at the second report in that same spot. Anyone notice a difference there anymore? Rubles, yeah, exactly, rubles. So what happened with this was, you guys got the bug correct, you got the issue correct. The report changed, and this actually happens to us all the time. DSPs are constantly making small changes to reports. They do not tell us in advance, they just do it. And if our system cannot handle a different format, or can't at least tell us it's a different format, we have problems. So in this case, if you look at our data model that we put here on the right, I kind of highlighted for you where our problem was. We knew that in the original report that the USD total was stored in column 16. The new report came in, and all of a sudden, the ruble total was stored in column 16. Rubles are worth about a 70th of a dollar. So when we processed the ruble total and started showing it to our customers, everyone was ecstatic. Everyone said, this is great, I've never made so much money on Yandex in my life, let's keep going. Until we discovered that the money in the bank didn't seem to match up with the money on the reports, because we had a very simple problem here. We were processing rubles as if they were dollars. And the reason this happened was we violated SRP. We didn't conform to the rule that said, make sure there's only one thing responsible. There's only one person that cares about how your class behaves. In this case, our parser was responsible to two different reports. It was responsible to what we now call version 1 of the Yandex report, and also what we now call version 2. There's also another problem here that's a bit harder to see. Our parser was responsible to determine whether or not it was the correct parser for the file. And because the programmer who implemented this chose to use an index instead of like a column name or checking the header or anything else, so it worked, right? This is a silent bug. We had no way of knowing about it in the beginning. If we had followed SRP properly, if we had a system in place that was designed to identify parsers, this couldn't have happened to us, because when we made a change, or when the Yandex made a change, we would have known the correct place to look. We would have known to say, this is the system responsible. This is the one who's in charge of identifying which parser is the correct parser. I can't hear. Why do you parse based on the column name? One parser? That would solve the problem if you did column names, but you're still then mixing the responsibility of identifying which parser is supposed to do something, which parser is responsible for the file, with the responsibility of actually parsing the file. So you know, whatever put it into that part of the pipeline, you already know where the thing is coming from. Well, we know it's from Yandex. We don't know if Yandex has changed their version or not. Right, so you should make it explode horribly if it hasn't validated. In this case, it didn't. Right? You're right, we wanted to explode horribly. The reason it didn't in this case was because we left the responsibility of figuring out, should I explode horribly, or should I go ahead and try this in the hands of the parser? And the particular developer that implemented it didn't have that in mind. He just said, let me go ahead and implement a parser that can handle this Yandex file, and he did it perfect. His version works exactly the way the original file was supposed to. When the new version came along, he hadn't considered, again, because of an SRP violation, that I need to handle some other version. I need to explode horribly, to use your words, if a wrong version comes in. And so what we did to fix this, and this is part of one of the things in our new system, is that we actually factored out a new parser identification system. So we now have a piece of our code that is solely responsible for figuring out when we get a report file, who's in charge of this file. That means that parsers no longer have to worry about if they're in charge of a file or not. Right, there's a separate system that does that, and there's actually OCP implications to how we designed that. You can discuss that with me later, since I'm not allowed to talk about OCP in the interest of time. And then the Yandex parser itself, obviously, once we knew where the problem was, we actually made two parsers. And this is where this gets pretty interesting. Because the two parsers, if I just show you the source code, they're like 95% the same. Line for line, 95% the same. Which means the first thing that people ask when they see it, whenever we have a new dev that sees one of these parsers, or says, this and this are the same, what about dry? Everyone here has for sure heard of dry. Don't repeat yourself. It's one of the first things we teach you. So what about dry in this case? And that's actually where SRP drives us to go in a different direction. SRP will actually override dry in some cases, and it will tell you dry code, or what appears on the surface to be dry code, can be dangerous, because it can force you into creating a dependency without realizing it. You can say all of a sudden, I have these two different things, completely unrelated, both dependent on my so-called dry code. As soon as someone changes that, system breaks. I'm in trouble. And I have my own acronym. I put it up here for you guys. This was actually thought up by one of my students about 4 years ago, I think. The acronym is DAMP, just because we have dry and wet, so we have to have damp in the middle. So we have DAMP, which is done again, maybe permitted. The only reason I like the acronym is that it helps us understand that there are cases where we should not blindly follow principle. This is true of all principles, by the way. This is even true of SRP and all the solid principles. There are guidelines. Dry is a guideline, SRP is a guideline. In this case, it would have helped us a lot. We would have avoided the problems we had in the first place with the Yandex. Let's take a look at a second example here. So I want to talk a bit about an FTP client. This is actually a really interesting one. FTP is an ancient technology. It was actually first launched in 1971. Anybody know when SSL was first launched? Okay, it was first launched in 1995. That means that FTP existed for 24 years before there was such a thing as encryption, or at least a standard online way of handling it. During those 24 years, obviously, it was completely unencrypted. We sent all files completely in the open. That meant there was a very, very well-entrenched system throughout the entire internet of transferring data in an unencrypted fashion. And a couple of years after SSL came out, in 97, they came out with something called FTP over SSH, which is the same thing as FTP. It just runs over a encrypted connection. Anyone want to take a guess how many people have implemented that? This was in 97 that it came out. We're in 2021 now. How many servers do you think use FTP over SSH? 1,000? FileZilla is not. Oh, it can. You can set it to. All right, so the answer is that by default, right now in 2021, basically every FTP server in the world does not use SSH. It's a shame, right? But that's the reality. That's the reality of what's going on. Now, we at Revelator said that's terrible. We don't want to send sensitive client financial data over an unencrypted connection. We want to force onto all of our connections that send data that they must be encrypted. And so we had this awesome idea. We put into our FTP client, if you look at the highlighted line there, that it automatically sets what's called explicit encryption. That means that we don't talk to a server if it doesn't let us encrypt the data. Really cool, right? We put this into our client because we want to make sure that every single person that sends data from our system uses the encryption. And the best way to do that is to put it straight in the client. Anyone spot the SRP bug in this? SRP violation? What do you mean? All the servers that we connect to have an option. If you choose, they have an option for secure. Good. Okay, so exactly. Right now, the way the FTP client is written, the standard for SSL, that means which version. Are we on SSL 2, SSL 3, are we on TLS 1, 1.2, 1.3? That standard is determined directly inside the client itself. And that didn't seem like a big deal to us at the time because who cares? There's defaults. The system is designed on it. We don't need to worry about it. Until one of our stores said, hey, we need to use what's called TLS 1.2. It was at the time, relatively new version of TLS. It was supposed to be better, and we needed to support that connection for them. So we added this great line of code. If you know any C#, you should recognize the service point manager here. This basically says, use TLS 1.2 when you do connections. Awesome. What happened? It didn't crash. It didn't crash, but what happened was that every single other system we connect to stopped working because they weren't configured for TLS 1.2. And we put it inside the client. So because we broke SRP, this is exactly a classic regression bug. We made a change inside of a system that we didn't think would impact anyone else because we said, it's the client. Of course we get to choose inside the client how encryption works. We made the change. We stopped being able to deliver to anybody. We deliver thousands of releases a day to stores, which means that we had to actually take our system offline for a couple hours to be able to diagnose this and fix this and redeploy it. We had no idea what was going on. All we knew was that all of a sudden our FTP was exploding everywhere we looked, and we were getting error messages everywhere. This is something that we never would have run into if we'd followed the principle in the first place. Thankfully, once we identified the solution, it was super easy to fix it. You can see here, all we had to do was stick in a parameter that says, you can choose what mode you want, and we put a default, right? We said, we want you to use encryption, so we're going to set a sensible default if you don't have one. Okay, and now I'm gonna talk about my absolute favorite SRP bug. I call this one, how did I end up in this account? I'll give you one guess why it's called that. We managed to, the short version, which you'll find out more of the details in a moment, we managed to give access to other people's accounts with a bug in SRP. We let people log into someone else's account without having any authentication to do so. You'll see how we manage that in just a moment. So just a little bit of background. This is important to understand what happened here. We have a system where we allow every single username, that means every combination of email and password, can have access to multiple tenants. So our system supports tenancy, which means that even though it's only one server, we can have a lot of different people connected to that, having their own set of data running on that server. Second thing you need to know is that we have what are called white labels. If you're not familiar with a white label, it means that someone else pays us to be able to sell our platform as if it's theirs. For each of them, they have their own tenant, they have their own clients, and they want to be able to manage their own clients and interact with their own clients as if it's their company. And the last big important piece is that we have only one auth DB. All authorization data for all tenants, whether you're a white label or whether you're us or whether you're a direct client or anyone else, all auth data is stored in a single database. That's good in some senses. It means that we can easily switch between what system we're accessing, but it also can lead to some problems, which we're about to see. So I have on the screen here our original validate credentials method. I actually think it's not called validate credentials. I forgot to change the name there. It's called create session, right? Yeah, create session. This was the method that was responsible for actually generating a session once you successfully logged in. I'll give you guys 30 seconds really quick to see if you see where the SRP problem is here. I still have this screen. Okay, so this is our original method. If you remember what it said on that screen a minute ago, what it was telling you was we had to choose a default tenant. If we had a guy who had 3, 4, 5 tenants, when you first log in, we have to show you one of them. And from our perspective as programmers, we didn't care. Show you whichever one, we'll pick the first one on the list and show that to you, and you can choose afterwards. We have an account chooser. Click on the correct one. There is a line in there, which hopefully will show up in a minute, that it says get default tenant, which all that did basically was it looked in the database for all the possible tenants. It chooses out of all the different tenants that are available and just picks a default one, which just means the first one. What we did was we added an impersonation feature for our own admin staff. We were having problems where users would say, I see something, we could not reproduce it, our debug logs didn't leave us information. We had a lot in the debug logs, but it wasn't enough. So we wanted to impersonate them and see, do we get the same behavior or not? Simple enough thing, you can see the code's really easy here. We just check, are you part of the admin group? If you are, we let you impersonate. The next thing we did was we said, hey, our white labels want to do the same exact thing. Can we let our white labels have access for their children that they should be allowed to log in as one of their child accounts? You can see, if you know any link, that this is it gives us the ability to check, does the target account belong to Ki'ilu, whoever the parent account is? Looks simple enough. Here's the problem, though. This check still uses the create session method. That create session method still chooses a default account based on nothing, just based on whoever's first in the database. So if we have a user who is a member of a white label, and he's also a member of something else, he has his own private account, he has maybe an account with a different white label, and the white label impersonates him, there's going to be kind of a lottery going on if they end up in the white label account where they want to be, or in the guy's personal account where we don't want them and the guy doesn't want them to be. And what happened was, as we discovered, we got a great catastrophe. We actually ended up being contacted by a white label and told, hey, I don't seem to be in the right account. I clicked on impersonate on Ploni Almoni, and it says I'm now in some completely different platform I've never heard of, some different distributor. Why am I here? What happened? And this is actually a really big deal, obviously, right? Because we exposed private data. We informed a customer, one of our clients directly, the white labels, that their customer is working with a competitor. We gave them control over that customer's financial transactions. If they wanted to, they could have logged in and made havoc, made payments different, changed his contracts, added themselves, done who knows what with it. This is a very serious breach that all came out of a seemingly innocuous problem in SRP, because we messed up where the responsibility was, or who should be in charge, in other words, of deciding what session, what tenant do you end up accessing when you first log in. Thankfully, I presented this in extreme way because it's more fun that way, but this actually happened inside of a private test environment with one of our white labels. It was with a white label. This really did happen with the white label, but it was in a private test environment. They were the ones who requested the impersonate feature, and they were seeing if they could do what they wanted to in our private test environment when they told us. So it was limited damage, but it was still real damage. And if we hadn't launched into the private test first, if it happened to be something that went straight to market, it would have been much more severe. These types of things really do happen. They are very severe when they happen, and we have to be very aware of them and make sure that we don't end up with catastrophe. So I want to quickly talk about ISP. ISP is the interface segregation principle, and just because I think that one of the coolest things that we've ever accomplished in terms of programming comes out of ISP. And that is, if you look here, I have a bunch of for each loops. Depending on what language you're in, this might be called a for loop or a for in loop, or every language is a bit different, but the concept's always the same. I have some kind of group of data. I want to do an action on each of the items in that group individually. And if you look here, I gave a bunch of really different types of data. I said I have a DB query. I have files on a file system. I have an array. I have letters inside of a string. I have an XML document, and I have rows out of a CSV file. Those are all dramatically different in terms of how they store the data and in terms of what it means to access a row. Some of these things allow you to have what's called random access. You can go back and forth easily, and some of them are one-way only. This is all possible because of what you have on the bottom half of the screen. This interface is called an IEnumerator. This interface defines for us two really, really, really small operations that it takes to be able to support for each. All you need is, number one, tell me what I'm looking at right now, and number two, tell me if there's something else. Every single one of these types of things, a database query, a CSV, a file system, can implement its own version of how it handles an IEnumerator. And because of that concept, because the team that created for each, the C# team in this particular case, but similar teams in every language, they recognized what needed to be separated out. They were able to take the exact same algorithm and use it for completely different types of code. And I just think that's a really amazing thing that they were accomplished, because this is pure ISP that let us do this. Interface segregation. Identify the interface that is the smallest amount you need for whatever type of code you're writing. Okay, I'm going to do a quick review on what we talked about. So first up, SRP, what I spent the most time on. It's all about making it safe to make changes. That's really what it boils down to. We know we're going to make changes. Let's make sure we can do it in a way that doesn't hurt us. At the end, it makes you less likely to have regression bugs. ISP makes it easy to reuse core algorithms. And the other stuff that I didn't talk about also have plenty to tell you. You'll have to go out and learn them on your own. Just want to finish off by saying, design your code with the future in mind. This is kind of where I started, kind of where I'm going to finish as well. Everything I said tonight, everything you'll ever learn about software development boils down to this. We know change is going to happen. We need to make sure we design for that change. I don't want to tell you to take it too far. There is a big risk. I see this a lot as well. If you apply all the solid principles to a code base over and you iterate over and over and over, you end up with code that's impossible to manage. Because every principle will tell you, if you take it to its extreme, you haven't gone far enough. There are more responsibilities here you didn't consider. There are more problems in OCP. There's more interfaces you didn't consider. When you apply the principles, that's why I have here that you do it with the future in mind. You don't know exactly where you're going to end up, but you can predict roughly the type of direction you're going. You can predict what types of use cases you might expect. Apply the principles based on those types of use cases. In terms of the impact of this all, just before I came today, I did a quick search on Glassdoor in Tel Aviv. Glassdoor says that anyone with the title software developer right now gets about 25,000 shekels a month, and someone with the title software architect gets about 36,000 shekels a month. That's an 11,000 shekel difference, and the difference between those two titles boils down to how well you understand this stuff. If you can do this easily, if you can craft your software easily, if you can apply these principles, if you know which ones to apply, when, and how, you can call yourself an architect. And you can get that extra 11,000 shekels a month. This stuff makes a huge difference in your career. I can tell you personally at my company, when I hire, if I see a guy in an interview who knows this really well, I'm much more likely to hire them than someone else. I want people on my team to understand how architecture works. Even if they can't be the architect, I want them to understand that architecture. All right. There's no shortcuts in any of this. This took me, I know this because I've been doing it for 18 years. There is absolutely no way to just learn it overnight. The only way is to start now, reviewing. When you make code decisions, think about these principles. Think about, did I consider them? And if I did, how did they apply, and did I apply them properly? And the more you do that, and the more you iterate over it, the better you're going to get. And that's all I have for you guys. So, any questions? Sure. I'm getting off easy. Yeah. About? QAs don't solve all regression bugs. QAs cannot find all regression bugs. You don't believe me? Okay, let me put that differently. We had a QA. Our QA tested the system and verified that the behavior that was spec'd by product was met. The behavior that was spec'd by product said, when a white label account attempts to sign into one of their child accounts, this is what they see. It happens to be that the account the QA tested in didn't have the same behavior, either because it didn't have access to many accounts, or because the first account in that particular list was the white label account. Right? Since the bug behavior only showed up under a very specific set of conditions, QA can't catch that. So in MVC, this is true for all MVC frameworks, not just .NET. The biggest problem that you always have is that it pushes you to use the exact same data model, same DTO, for both your database and for your API side. You have a single DTO by default in basically every setup I've ever seen. That is a violation of all kinds of these principles, and it leads to tons of problems. If you're relying on the defaults, you're going to run into that. And you're going to run into other ones. I see it in tutorials. I see it in Microsoft documentation. Bad code all over the place that does not follow principles. It's definitely helpful. It does a lot of the work for you, but it's not an excuse to be ignorant of the principles or ignorant of the way they apply them. Well, you're talking about on the front end, the view model. Which framework are you in? There's a couple different ones you might be in there. You're an MVVM view model? Okay, so if you use the view model correctly, yeah, you'll have two different models, but not every tutorial is going to set that up properly. It's faster and easier, and there is more tooling to do automatically if you have the same models all the way from the database to the end. So that's what they push you to do, because if I want to focus on teaching you MVC, I'm not going to waste time explaining to you why you should use different models and how to map them, and it's a ton of boilerplate code. I don't want to waste time on it. It's the wrong choice. No, functional programming can and should do solid. Every single thing I told you applies to functional programming. If they tell you otherwise, it's because they don't know what solid is. There you go, I have backup. All right, guys, there's no other questions. If you? Probably. You can make it look. I'll tell you something I always say. This is true in programming especially. People make a religion out of it. You will see frequently people that say, you have to have spaces instead of tabs. You have to put the brace on a new line instead of on the same line. You have to pick any point within it. SRP is the only thing that ever matters. Make sure you always follow SRP, and if you don't, your code's horrible. I cannot tell you how many articles I've read by people telling me that I'm going to bird and who knows where. If I don't follow their advice, that's going to solve all my problems. It's not true. You can take anything too far. You will break your code with even these principles if you go too far with them. Yeah. Yeah. Because in each one of the examples, if we'd followed SRP in them, the likelihood we've had the same bug would have been, this is my opinion obviously, but I'd say we're somewhere around 10% most. In each case, the driving force behind our inability to understand why the bug would happen was that we had misdelegated our responsibility. We hadn't put the encapsulation on the right level. This one. So what we actually did was we changed the way sessions work. So instead of the session being responsible for identifying, it's what's called our permissions account. That's the kind of the name we use for identifying the connection between the user and the tenant. So instead of the session being responsible for generating that, we provide, when you create a session that has no tenant attached to it, and it's the responsibility of the calling code to attach the tenant. We also created tools to do something like get a default in a situation where that made sense. But in a situation like a white label, then we have tools that will allow you to say, here's the white labels that are accessible, or sorry, the tenants are accessible to this particular white label, and you can only choose from that list then. That's one way of summarizing it. That's why people say that it should do one thing only. It's one of the things at the beginning. Right. And so, again, it's not an impossible definition. It does work, but I think that it doesn't get to the main point of it. That's absolutely true, right? So we have to whatever degree possible, we have to have it in mind when we design it. It's about the responsibility. The problem here was that this code is responsible to the tenant and to the session, which are different concepts. That's where we had the SRP violation. All right, I hear you guys starting to talk. I'm going to go and close down. You can ask me more questions up here privately if you want.